Hi folks, it's time to talk about greatest common divisors and least common multiples. So on the opposite end, we have something called the least common multiple. So if I give you two numbers A and B, the least common multiple is the smallest number that is a multiple of A and also a multiple of B. And again, we can calculate it in three different ways. Two of them are very similar to what I had before. I can use a listing method and a prime factorization method. And I can also use the GCD, and I'm going to show you those in the next few slides. So to find the LCM by listing, I am going to list the multiples of both numbers, and this time it's the least common multiple. I want the smallest number on both lists this time. And just a little friendly advice, you don't want to go crazy on one list of multiples and make it super long and find out you really only needed a very short piece of it. I'd keep both lists of multiples kind of going so that they're at similar sizes and build them both as you need them. So I want to find the LCM of 12 and 10. So remember, to find multiples, you just keep adding copies of 12 to itself. So 12, the next one is two 12s, that's 24. Add another 12, three 12s are 36. Add another 12, four 12s are 48. Add 12, you get 60. Add another 12, you get 72 and 84. And then I'm going to write my multiples of 10, 10, 20, 30, 40, 50. Oh, I see 60 is on both lists. So the first number on both lists is my least common multiple. Another way we can make a least common multiple or discover it is by factoring into primes. So factor both numbers into primes just like we did for the GCD. This time I am going to take the larger power of each prime. And so this time, if a number is a prime in one factorization and not the other, I definitely want to include it this time. So the LCM of 12 and 45, I factor 12 into 2 squared times 3. I factor 45, that's 9 times 5, or 3 squared times 5. The LCM, I have powers of 2. I have 2 squared versus no 2's, the bigger is 2 squared. I have 3 to the first versus 3 squared. The bigger is 3 squared. I have no 5's versus having 5 to the first. The greater of those is 5 to the first. So we have 2 squared times 3 squared times 5 is going to be my least common multiple. And that's going to be what? 4 times 9 is 36. 36 times 5. I'll give you one of my favorite tricks to multiply by 5. Just put a 0 on the end of the number and then take half of it, right? Because putting a 0 on the end multiplies by 5. Taking half of that, putting a 0 on the end multiplies it by 10. Taking half of that makes multiplying by 5 instead. So 2 squared times 3 squared is 36. I put a 0 on the end, that's 360. Divide 360 in half, that's 180. So 180 is going to be 2 squared times 3 squared times 5. So the LCM of 12 and 45 is 180. So here's some LCM problems for you to do as prime factorization method examples. So see what you get. There's nothing wrong with checking your work by listing if you like to do that. So stop the recording and give these a try. And here's your answers. Take a look and then move on. Now the third method, we don't use the Euclidean algorithm to find LCMs, but you might have noticed something. Suppose I have two numbers A and B and I want to find their GCD and LCM. So I factor the A and the B into primes. And as I find the lesser power of each prime to find the GCD, I could cross those off. And as I cross them off, I look at what's left. What's left is actually the LCM, the bigger power of each prime. So that helps me notice that if I took the GCD, those are the smaller powers of each prime, times the LCM, the bigger powers of each prime, and I multiplied them together, I get the same thing as if I multiplied A and B together in the first place. So I could divide and I figure out what the LCM is. It's A times B, I know what A and B are, divided by the GCD. So here's a nice formula. And you might say, well, I still have to find a GCD, Debbie, and this seems awfully complicated. But it turns out that finding multiples can be pretty ugly because you never really know how far out to list all those multiples or to multiply together those powers of primes. And so this is a lot better. So let's see, if I have to find the LCM of 102 and 26. So I'm going to find the GCD. The GCD is something that divides 26, and not very many numbers divide 26. 1, 2, 13, and 26. I could check that 13 does not divide 22, so I know that 26 doesn't divide both 26 and 102, and 13 doesn't divide both of them either. Now 2 does, so 2 would be the GCD. So to find the LCM, I just multiply 102 and 26 together, my A and my B, and just divide it by 2. And so here it is. I've repeated myself a bit, but that's okay, I guess. So we find out that the GCD is 1,326. And if you think about that, that is the 51st multiple of 26. So you would probably not like to write down 51 multiples of 26. And by the way, 26 multiples of 51. That would be a lot of listing. So this is a much quicker way of figuring things out. GCDs are generally faster than LCMs.